Okay, we should be live. Oh, this is super bizarre. This is a test. Can I hear? Nope, I can't hear. So that doesn't work. There we go. Okay, so does the audio sound all on the left side for you guys, or is it mixed into stereo? Because on my side, it looks like it's actually coming out mono. Let me do some tricks. Okay. Okay, yeah, that's kind of what I thought. So I'm actually using a mono mic at my throat here. So I gotta figure out how to down mix that. And this is why I started early, so we can sort this stuff out. Test, test. Nope, that ain't gonna work. Oh man, I'll have to sort this out later. Video signal is not interlaced. Hey guys. Yeah, unfortunately I'm going in through an Atom Mini, so unfortunately, yeah, that's just the way it kind of goes. Let me see if I can fix the interlacing issue. You're saying it looks like interlace? Actually, it looks uninterlaced to me, so it might just be the video quality. Yeah, there's no interlacing in my streaming settings, so we'll just have to deal, I guess. Give it another 4 minutes, and then we'll actually start the stream. Like, officially start the stream, besides, you know, this. I am actually not on Windows. I am actually running Ubuntu 2010, and I don't actually have a Windows machine that I can use for any of this stuff, so you'll have to bear with me on that one. Okay. For all you Emacs folks, how does the chat look on the left? Can you guys actually read that? I just want to make sure. Oh God. Yeah, so I'm definitely an open source lady. I very much prefer to use open source if I can manage it. Yeah, unfortunately, Matthew, I still don't have a good solution for running the Atom Mini control software. I'm still working on that. Hopefully, I'll have that fixed for the next session. Until then, please bear with me. It will be primarily just mono. So hopefully not tinny, but I am using a lapel mic right here. So if it's too much of a problem, I can switch over to using my Yeti. I prefer not to use it because the noise cancellation is not great. Lapel mics tend to do a better job. Okay, cool. Well, then we'll just keep it that way. Because we're actually going to be doing some camera swapping. So I actually have two cameras set up. I've got this one here, which is kind of up high above my monitor. All my monitors are kind of like in a giant portrait layout. And there are some things physically that we're going to look at. And we're also going to... no audio? Okay, so then that's an interesting problem. So I would say check your speakers. I'm going to see if I can do something about the mixing on my end. I don't think I can actually do a whole lot because of the way I'm bringing audio in. Yeah, it doesn't look like I can actually change it on my side. Oh, I see. Hang on a minute. That's the issue. Almost there, guys. Sorry. Let's try boosting the mic level a little bit. Hopefully that'll make things a little better. June in June. Indeed. Yes, left channel is on mono at the moment. Aha, okay. I'm going to stop the stream just for 5 seconds while I adjust some settings. Hang on. I'll be right back. Hang on. Okay, so I am back. Audio should be in stereo because I'm recording in mono now. And hopefully the audio is a little bit louder now. So folks can let me know. How's it sound? All right. Okay. Right, so we are now 1 minute past, so I might as well start this whole shebang. Welcome to the first ever Nibbles and Bytes streaming session. Never done one of these things before. I've done a lot of presentations and stuff. I've actually done talking in front of groups, but I am pretty nervous, so please bear with me. So we have a few things that we're going to look at today. The first thing is that, yes, this is the first video, well, video, if you will, that I've done for a long hiatus. You can see this room is actually quite cluttered. So things are going to change in the next few months. I'll have a better space. We'll have hopefully better streaming capabilities, better video editing capabilities, all this stuff. So more stuff in the works. But the big thing I wanted to reveal today, relating to some of the other things that I've mentioned both in the Discord channel and then also on the YouTube community section, is this project that I've been working on the side for a little while. And I call this the V128 project. So essentially, I had this crazy idea. You know, I've been sitting in front of these CRTs for so long. They've been giving me migraines. And I've had this problem ever since I was a kid. This is actually a big problem for me. So I started working on a small version of the Commodore 128. And initially it started out as just a keyboard project. So I designed a 104-key keyboard custom layout specifically designed for Vice. And I kind of alluded to that in one of my Vice videos. But the other half of this is that I wanted a machine that everybody could get their hands on. We've always had this problem of there weren't a whole lot of 128s made. And they're not that popular. They kind of die over time. We're dealing with custom silicon. It's like, it's a problem. So let me switch over to the other camera here, and I'll show you guys what I'm talking about. So this is the prototype of the 128 Mini. And it's kind of hard to see because my camera's not the greatest for this side. I'll have to manually adjust. Yeah, so this is effectively a scaled down replica of the 128 modulo the floppy drive door, which I'm working on. But this drive slot is going to be functional. So effectively, and you can tell it's a prototype because the case doesn't really fit right. So still working on that. But essentially, this is the top half of the case. You can tell mechanics are not 100% yet. And then let's see if we can get this to autofocus. There we go. So yes, this is actually Pantone matched color. So I actually worked with Matthew Wilson to come up with some filament for 3D printers that would match the beige color of the machine as close as we could get. I'm hoping that we can maybe get even a little bit closer, but this is about as close as I could match at the moment, without doing a custom order, I should say. But essentially what you're seeing in here is a Raspberry Pi 4 compute module. And the compute module is important in this case. Instead of using a regular Raspberry Pi, we're going to use this compute module and I/O board combination. And the reason behind this is it gives us the ability to add in custom boards and custom baseboards and stuff. So right now, you can see on the back of this, we only have 2 HDMI ports, which we're going to need because the 128 has both the yeah, got the DCRs back over there. This is actually modeled from that case, and we will be continuing to use that. Just so you know, this is not 100% replacement. So Vice is not really totally there yet. We'll get there. We'll get there. But for now, this is to make sure you guys can start following along with the channel more, for those of you who can't get a real DCR. But the idea here is that we're going to spin a custom I/O board. And this is going to include some additional connectors. We're going to have a 9-pin connector for a joystick port. And then I'm also going to add a DIN connector so that we can basically plug in a 1541 or 1571 or any other IEC-based floppy drive into the system. And in theory, it should just work. Now, the other side of the coin, you may notice this silver patch. This is an aluminum foil patch that I've attached to the top of this drive bay. And the idea here is that this drive bay is actually functional. So, for instance, if we've got these little floppies, you can see it's got this little patch on the bottom. And this patch actually has an NFC inlay behind this chunk of PLA. So the idea is we insert this into the drive bay, and unfortunately the fit on some of these is not great. Working on that. Slides in, and then we're also going to have an additional board in here. This is called a PN532, and what this is an NFC reader. So this is going to sit underneath, and this is why we have the aluminum patch here, for instance. And I've got some double-sided tape on there. It's a little bit old, but it hangs onto the back. And when you insert the NFC, it will actually read this and trigger an interrupt on the Raspberry Pi. And effectively, this allows us to then read the NFC chip, figure out which floppy disk is inserted from the NFC name, and then trigger a floppy switch in Vice. So to do this fully, this is going to take some changes. This is going to require some changes in Vice. It's going to require some work on our part to make these floppies work. Unfortunately, one of the side effects of using this particular technology, good grief, the fit on that is not great. I have other ones that fit better. But these NFC chips don't have enough storage to actually store the full floppy disk. The biggest I can actually store in here is 8K of data. And when you think about it, a 1541 floppy disk, one side of it is, I think it's like 200 some odd K, give or take. And so obviously we can't really fit the whole thing on here. But what we can do, yeah, 64 gig NFC, I wish was a thing. Unfortunately, it's way too power hungry for that kind of thing. So the biggest that you typically get is about 8K. And that's if you're lucky. And the other side of the coin is that the bigger you get, the bigger the inlay gets. So this inlay is about 1 millimeter thick, which is effectively like 2 or 3 layers of plastic for this floppy disk. So this inlay only has like, yes, thank you, Blackie, 170K, 1571 is double-sided, so that's 341K. But this inlay is almost too tall. That's why it doesn't fit quite right. Some of my other discs, I think, like our friendly little jingle disc here, fit a little better and just slide in and out. So hopefully we can get this working, and you can see the inlay on this one actually a little bit better, because this is literally 1 layer of plastic. So the plan is to get this thing working and make a few changes for Vice to actually make it work reliably and output to both of these displays quickly and efficiently. So we're going to plug this in, and I'm going to demonstrate this thing actually booting by way of the Atom Mini here. And unfortunately, I can't do dual head with the Atom Mini, so we're just going to have to sort of wing it with a single display. And I will turn on picture-in-picture so you guys can see. Oh, you can't actually see. Dang it. I should have tested that before I tried. Oh no, crap. Secondary cam, there we go. So it takes a little bit for it to boot, but once it actually does boot, you'll see the, God, there's a delay. I'm totally not used to that yet. But once it does boot, you'll see Vice come up, and then we can actually use this thing as it's intended. Takes a little bit. In the meantime, let me show you the keyboard. And this was announced a while back, but this is literally just a 104 standard keyboard with a custom silk screen on the top. So all of these keys work like a normal key. The trick is that this is mapped to control in Vice, and this is also based on the GTK3 key map. This is not the SDL key map. Needs to be much bigger, yeah, I know. So this actually came from WASD keyboards. Unfortunately, they don't give you much choice in terms of color. So you have white, black, and I believe it's stainless steel brushed for a much bigger expense. So the best thing I could do was get white. We can investigate doing other colors through other vendors down the line, but for now, this is sort of like the prototype kind of thing. And it's at least guaranteed that all these keys match up. It will recognize these keys in GTK3 front ends. In the SDL front ends, you have to use a custom map that I will be distributing shortly. Hopefully after the stream, I'll get a chance to put it up online. But if we plug in the keyboard, we should be booted by now. And there we go. So at this point, we've got Vice running. It actually boots to Vice straight up. There are some things I need to iron out, such as the boot process. It should be faster. Obviously, we also want to make it work a little more reliably because I have had some freezes here and there, but effectively this works just fine. So we can actually give it a program. And then run, and hello world, and all the keys pretty much work. And again, this is a Raspberry Pi. So if you wanted, we can actually get to a shell. I don't know how this is going to render on this particular screen. I may have to adjust some things to make it visible. But effectively, you know, we have a standard Linux shell available, and we can use that as a standard computer as well. Ideally, this should be as plug and play as possible. We don't really want this to be confusing, right? So like we want to try and stay away from this stuff and stick with the emulated Vice system. So I'm trying to gear it more towards just plug and play, you know, plug in a disk, get it going, that kind of thing. So I was anticipating that a little bit. So I've been trying to do all of this stuff open source. And so if we switch over to Firefox, if you go to v128.info, oh yeah, this is not HTTPS, by the way. This is just HTTP. But v128.info goes to GitHub, the v128 team group. And this is effectively where I've got all the source code. So this is essentially a whole bunch of repositories to do v128. I would love to use that name. Unfortunately, I would be concerned about trademark issues. So the 8-bit guy and Parafractic actually ran into this as well. So I'm kind of treading on thin ice here. I have not done a trademark search. I don't know if v128 is going to work or not. I'm just going to go with it and make it open source. We're not going to do this as a commercial endeavor. We're going to do this as an open source group project with all the sources and everything available, including the hardware. So if you want to print yourself one of these things, we actually can. I've got all of the STLs up on GitHub already and assembly instructions, including the bill of materials. Chicken lips. I love it. So you can actually build one of these yourself as long as you follow all of these instructions as well as the bill of materials. The keyboard layout is also up here. So we've got the vectorized SVG up here. So if you can't get to the v128 keyboard on Westy because their layouts kind of, or their website's kind of janky, you can also follow this link, or you can actually take that template and then send it out to have these keyboards set up for you. Effectively, as I said, it's just a 128 key extended keyboard. So, and you can see it's anodized, gray, silver, black, or white. So that's kind of our choices. So yeah, that's the v128. And the things that we've got to work on, at least in terms of the software here, Commodore 128D-, I love it. So let's go back over to an editor, and let's actually get this thing, give you a short tour of the software itself. Obviously, I'm running on Linux. I don't have any plans to make this build on anything but Linux at the moment. Part of the reason for this is because the build system itself is actually generating a Linux distribution. So this is actually not like bare metal BMC64. So this is actually running a Linux distribution. So if we go into distro, you can see I'm using this tool, gosh, what's it called? Called Debos. And Debos is actually a tool that will generate a Debian distribution image from a YAML file and a set of files that you generate yourself. So inside of here, you can see I'm actually just bringing in all of the base level system that we need for a Debian system, which is why I was able to open up cool retroterm on this thing and then get to a shell prompt. But because of this, this means you have to be running a Debian-based system. So unfortunately, to contribute to this in terms of software, you'll have to do that. You'll have to be running Debian. Alternatively, there are other parts of the system that do need work. So we have the distro, we have documentation. Basically, we need help with the mechanicals of the system as well. For the mechanicals, we are using another tool called Onshape. And Onshape is this web-based mechanical engineering CAD tool. And out here, we can collaborate by way of this. Everything in Onshape is public, unless you pay for the private aspect of things. But in effect, you can see this is the actual model, and we can tear it down and do all kinds of stuff. For some reason, it's not behaving, but yeah. So yeah, it's not rendering for some reason, but generally this works okay. And so if we want to work on this collaboratively, Again, it's on Onshape. We can actually go and modify the STLs. We can share them. We can talk about them. We have the Discord where we can share changes and stuff as well. So hopefully we can get that all working. Yeah, it's not wanting to load, so I'm going to skip this for now and go back to the source code, because that's kind of like, I am a software engineer. I'm not really mechanical. So back to the software. Right, so in general, most of our software is under the packages directory, and these are all Debian packages. So it's the source code co-located with the Debian tree. When we work in these things, for instance, this v128 shell, we have the source code here, and then we have the Debian directory above it. And then out below it, we have our top-level controls. We have a top-level makefile. We have a build directory. We have hardware, manifest, out, packages, releases, and USB boot. So distro is where we set up the Linux distribution. Build is where we have all of our makefiles. And then in here, we actually set up all of our rules to actually build the software. To use it, we source build setup. This does build Vice from source. That is correct. And you'll see it says platform set to Pi. When I first started this thing, I was using something called an Udo x86 Pro 2. I stopped using it because A, it's $200 for each board, which is a bit crazy. And then also it uses Intel integrated graphics. And unfortunately, there's a major problem in the kernel that they use, which is kind of it has a hang that I couldn't resolve. And this is actually deep somewhere inside of the Intel drivers. So I switched back to using the Raspberry Pi 4 because this is actually a much better platform for what we're attempting to do. Now, let's see. Vice is actually, Vice is in packages, Vice. And right now, we are using the Vice 3.5 release. So this is actually the release source. This is not from upstream SVN. But I am making changes in this tree. You can see I've already made some changes here. The big thing here is actually something I did yesterday, or I think actually it was the day before. I was actually managing to get SDL to output to 2 different windows so that we can have both the VIC output on one HDMI source and then the VDC output onto the other HDMI source. This doesn't build for the Pi 4 yet, but it's a starting point, and we can start banging this thing into better use. Ultimately, I want to make these changes upstream or available to upstream as well. So Black Stardust has been very helpful to me in trying to get this stuff working. So with any luck, we can get some of these changes upstream. Not all of them are going to fit, obviously, for obvious reasons. But yes, I am typing on a Toper keyboard. So let's see here. Secondary cam, and then, no, that's webcam, that's secondary. There we go. So secondary cam, yes, this is a Toper Happy Hacking Professional that my brother got for me. And I absolutely love this keyboard. But yeah, so once we've sourced setup, we can actually do a build. So if we say m Vice, and it's actually kind of Android-like because I'm an Android lady. I've been working on this thing for a while, and you can see it tries to build the Vice source code. But unfortunately, my changes broke, so let me fix this. Okay, so that should work. And now, if we do an m Vice, it'll actually go and try to... Oh, come on. I can't win. Packages, Vice, git status, git... Okay, I didn't change anything here. Okay, let's just use master and then m Vice. Wow, it really doesn't like me. Okay, so at the top level, I did mention this extra directory called out. And out is where we put our build artifacts. So when we go to out, right? That's the other side effect of using debos and debspawn, is that they require root. So this does kind of mess things up a little bit. That's why I put everything into the out directory instead of just co-locating all of our outputs with all of our source code. You can easily do a clean just by RMRFing out. But if we source build, or actually I don't need to do that. So Vice, come on. It's just not liking me today. So the configure routine is actually done in the Debian directory. So when we do a build, we're actually not building the source code directly. What we're actually doing is we're spawning up a tool called debspawn, which then triggers dpackage build package. And dpackage build package uses this rules file. And the rules file is just a makefile. So you can see it's actually doing a configure up at the start. So in theory, this should actually be configuring the system. But for some reason, it's not at the moment. And I'm not entirely sure why. Needless to say, this does actually build in upstream, but I left my tree in a bit of a mess. So I believe this is probably because, let me see here. So if we go into, build, and then we look at package build.mk, yeah, I essentially copied the Debian tree from the upstream Debian source. I don't expect most of those configuration options are correct. Debian tends to do a lot of odd choices in terms of what the configure routine is needed, in terms of what flags are passed to configure. So that may be half the problem. But we are attempting to, we're setting up this. So, okay, I guess I should step back a bit and explain how this works. So we've got this variable called Debian distro testing. This is just setting up a variable that we can use later. Out debspawn creates a directory in the out directory. We then have this file, which then generates this debspawn.json file. And that's a configuration script for debspawn. And it tells it how to fetch the upstream Debian configuration to make a sandbox when we go and build this thing. And the reason we build in a sandbox is because when you're building software on Linux, really when you're building software on any system, the thing you have to remember is your compiler and your host system, the machine you're building on, is actually bringing in parts of your host system into the software. And in this case, we're building a brand new operating system. So we don't want to bring in those host dependencies. That's going to be things like x86 specific libraries. That's going to be things specific to the way the compiler is built, and a whole bunch of other stuff. So instead, we use debspawn to create a ch root, essentially just a sandbox where we can go build software using upstream dependencies instead of using the host system's dependencies. And so that keeps us safe from bringing in things that are specific to my machine or specific to any other developer's machine. And to make debspawn actually do its work, we have to tell it to create one of the ch roots. So this rule creates a tarball that contains all of the packages and all the dependencies and stuff that it would need to do a build of the system. But obviously in make, this is pretty verbose. We don't want to sit there and write all of these rules every single time we have a separate package that we want to build. So instead of just building a massive set of rules, we set up this macro. And this is a little more sort of like advanced make stuff. But define build package sets up this macro. And we can then create these variables called package name, package arch, and package deps. These are arguments to the build package function or macro. So we're doing it in an eval block because otherwise these variables won't actually be defined. So we have to set this up. And you'll also notice that I'm using this colon equals structure. If we use straight equals, the problem is that this will not be expanded. So this will actually expand later in the makefile execution, and we won't get that argument. So we have to use colon equals everywhere. And effectively, the rest of this is just a whole bunch of variable definitions. Here, we're just making sure that the architecture definition, basically telling us which system we're building for, whether it's all RMHF, ARM64, anything like that. And then we have this other variable called package deps. So Debian packages have dependencies. And so when we build one of our packages, we have to make sure that the sandbox includes the other packages. So effectively, this is taking the package deps variable, and then it's walking through the list, and then finding the files that we built previously, and then adding them to the dependencies for debspawn. Now, you'll note these are called whale deps. That's because I was using an older tool called Whale that used Docker to do all of its work. Unfortunately, on Ubuntu 2010, Docker is not really well supported anymore, so I had to move over to using something else. And in this case, we're using debspawn. It's just, the name is a vestige of old stuff. Now, when we do a build of a Debian package, the typical way Debian works is they want to have this upstream source tarball. And since we're building with the source in the tree, we can't actually, we actually don't have a tarball, so we actually have to make one. And so these roles, these variables help us define where those tarballs need to be, and where the changelog is, and what the package version is, and all this other stuff, so we can figure out what the names of files are. We define a workdir. We define our DSC file, which describes the source tree, the source changes. And then finally, the package file name. So from this macro, we then define a whole bunch of these extra rules. So the first one is this workdir. And the first thing it does is it copies all the source over into the work directory. And I do this to make sure that the source tree, the actual source tree, is left pristine. We don't want to change the source if we can avoid it, because otherwise we're going to introduce changes that the compiler is making, and it just makes things really hairy. DSC file creates our DSC file using the source in the work directory, which is needed for dpackage build. And then finally, we have our package rule. So this is literally saying to make the Debian package, which we define up at the top here, you need to use the DSC file, the sources, the package container, and then we have a couple of order-only dependencies in here that say basically that we have to make the packages directory first, and then we have to make the debspawn.json file first. And the only thing we do is we go inside the workdir, and then we call debspawn build to actually go and build this thing. So this is why I'm confused why we're not actually triggering configure. After eliminating the out directory, and then also after cleaning up the environment, it's still not building for some reason. So I think there's something wrong in my environment specifically. So let's kill this terminal and we'll start again. So project is a shell script that I wrote. And this is just an easy way of managing my environment. So if we edit project v128, you actually can't see that. Dang it. Let me close that window, and we'll just open it directly. Lib. Oh no, it's going to be under Etsy. That's right, Etsy projects v128. So it's just a shell script that allows me to do fancy things like set up a special CD command that always sends me back to the project directory, and then also sets a fancy prompt so I know what my environment is. So that's all project does. That is also all open source on my GitHub. I believe it's under .bash is the name of the tree. So if you want to use it, you can. But effectively, at this point, we should have a clean environment. So I should be able to source build setup. And then, with any luck, here we go, mvice. Nope, it still don't like me. So if we just do an m, in theory, man, what is going on here? So build setup, and then setup has this function called m. M goes to the root directory and then calls make. So that means that this make file should be loaded, and the default target should be all. And then in packages, we define all of our packages that we want to build. So we say, here, this is where that macro comes in. We call build package, and then we tell it we're going to build Vice, and it is using the ARM-HF architecture. And this is important for Debian because ARM-HF basically tells it that that's a architecture-dependent package. You'll see that also down here we have the Plymouth V128 theme. This is our boot theme. When we turn on the system, we want to see that little fancy-looking spinner. And so we call this architecture all so that we can install that anywhere, regardless of the system. So when we switched from the Udo over to the Pi 4, we didn't have to change this at all because it's just generic scripts. There's nothing architecture dependent to it. Same thing is technically true of RPi EEPROM. RPi EEPROM actually does have architecture-dependent binaries in it, but we're not building it for an architecture. It's essentially a set of scripts. Arguable whether or not this should be ARM-HF or not. But essentially, build package here should be giving us a Vice target. So something is funny here. And we're not seeing any specific output here, which is telling me that this is actually trying to build. What on earth is going on here? The root dir is v128 build out. It's not even making the out directory. It's just literally trying to build the source for Vice. So, wow. Okay, I'm going to do something a little bit drastic. github.com v128 team manifest. And then, yeah, so this is the other thing I wanted to actually point out. So you'll note that on the website, well, on GitHub anyway, we have a whole bunch of repositories in here. And then we've got this top one called manifest. And the thing to know about this is that I'm using a tool called repo to manage all of these repositories. And this is because we're actually building multiple chunks of software. So when we go back to Emacs, I had to set up the repository by using this repo init. And effectively all I'm doing is telling repo to go fetch all of the repositories that are defined in the manifest XML file. So now, if I do a repo sync, it will then go and fetch all of the source and then bring it down locally. And this shouldn't take too long. Most of these repositories are quite small, with the exception of the RPi EEPROM repository because it has a lot of binaries in it. So, any questions so far? I'm happy to answer any while we're waiting. Yes, your comments are making it through. The keyboard is actually exactly the same as a standard 104 key keyboard. So let me switch back over to the camera. Oh, good grief. It did it to me again. I'm using the automatic switcher, so things are funny. So this keyboard is basically just a standard 104 key keyboard. You can see it's actually almost identical to my other keyboards, such as this Model M. So the keyboard layout is exactly the same, just like that. So yeah, so effectively this works exactly the same way that you would expect any other keyboard to work. So what's going on with configure? Not all of your comments are coming through, Blackie, it looks like. Ah, right. So the licenses at this point are effectively going to be GPL v2. The alternative here is that some of this stuff is out of my hands in terms of the licenses, because remember, we're building multiple chunks of software. So the v128shell, I actually don't have a license file in here, but it is intended to be GPL v2. The firmware, on the other hand, is literally just an upstream fork of the, it's a fork of the upstream source tree that also includes a Debian tree. The license on this is controlled by all of these licenses in here. I have thought of a 3D customized keyboard case. The trick with that is that 3D printed keyboard cases tend to be difficult to make at this size. The physical dimensions of this case, if we again go back to the secondary cam, the physical dimensions of this case, for instance, this is almost, well, okay, that's 155. Let me go get my other calipers. So you can see the width on this case itself is actually 200 millimeters. And the problem is that the size of a reliable 3D printer like a Prusa Mark III is about 250 millimeters wide by about 250 millimeters, right? So if you extrapolate that to the keyboard, the trick with this is you're only going to get like about half the keyboard case on that platen. So if we design one that's 3D printed using the same filament, we're going to have to solve that problem of assembling multiple parts of it. And the problem with that is it's not really obvious, but this is kind of rickety. And the trick is that this isn't going to have much in the way of mechanical stresses on it. You're not going to feel that creakiness of it, but this will. So if we use a 3D printed case, that's going to be kind of a problem. That's an idea, though. We could do actually an ergonomic split with the custom keyboard layout. That is something I have considered. So let's see. Has our clone finished? It's still syncing. It's still syncing about it. Sorry. Wow, my tools are fighting me, so one moment. Oh, good grief. There we go. Finally got it working again. All right. Okay, so still not there. So if we have this make file and we're calling make, and if we do this, echo root dir should say v128 old. So make, there's a way to get it to do verbose mode. Yeah, so this is going to make lots of output. And it looks like it's literally just hitting the vice tree and then just staying there. Okay, so if that's the case, let's do build log. So we're just going to go ahead and let all of that happen, and now we can go and find the file, build log. Yes, really open it. Emacs is funny. It really hates opening up really large files. But I think it can do the job. If slowly. Okay. Oh man, I think Emacs actually crashed on me. Oh, there we go. Yes. Yes, so there is the Commander X16, there's the Mega 65. The trick with those is that they are still following the Commodore 64 mode. And that's kind of why I started working on this particular problem and building a 128. Because when you think about it, a 128 is essentially just a Commodore 64 with additional bits in it. Okay, that's a lot smaller. Okay. We can live with one kidney. I love it. So let's see, CT1. And of course, this one didn't finish checking out, so we're going to skip that. And just use the old tree, because I think we need to figure this out. And you can see CD is alias to my custom CD tool, so it just brings me to the root of the tree. Now, let's just use less. So build log. And the first thing it does is it reads in all of its make files like it should. And then it starts considering what it should do to make the top level target. So my guess here is that the top level target is, wait, is it simulate? Simulate seems kind of goofed up here because it shouldn't be considering that target file. So if we go into build, yes, actually, that is actually the whole reason why I'm doing this. So I want to try and get more people interested in this system. So the more hardware that people can get their hands on, the more emulators that they can get their hands on, the better, because it means that this platform will just grow in popularity. We'll get better software for it, interesting more chunks of hardware for it, et cetera, et cetera. And the 128 is kind of a weird machine. It's not your usual Commodore 64. Like it's got 3 different machines in it. And so that makes for a really wacky development environment, but also there's a lot of unlocked functionality in there that we should be looking for. And it just feels like it's totally untapped. So let's, ooh. There we go. Let's see, so simulate should not be causing the issue. However, if we look at the makefile, and then we do this, let's get rid of all of these other includes. And the router is set up right, build scripts should be fine. All should then bring that up. And if we go into package build, I believe we add to the all target. Okay, so we are not bringing in the, okay, so it's all packages, which then brings in package name. Okay, so then if that's the case, then we go into packages, MK, and the packages also does not define all, which is good. So rootfs defines all as being dependent on rootfs. Rootfs is a phony target, which then calls clean image and then image. Image is the actual root file system image that we generate from all of these dependencies. Let's see, what else? Artifactor is out debOS, and the memory is 4096 megs, because we've actually got 4 gigs of RAM in this Pi 4 compute module. Actually, do we? No, we don't. So that's a bug. We should fix that. But let's see. package build packages prereqs. Prereqs does that. Okay. So all I can figure is somehow we are getting into this weird situation where there's a make file that's being brought in that shouldn't be brought in. So if I do make vice here, that shouldn't be calling that. That is so bizarre. Considering target file, out packages vice. Does not exist. So it targets that, targets that. Okay, so maybe you're onto something, Blackie. Maybe it's something relating to the automake. So we'll do a make dist clean. And that should hopefully allow it to build. Fingers crossed. Aha! That did it! Okay. So this is distinctly because GNU Make has this wonderful little feature where it has all of these additional auto rules added to it. So Make by default automatically knows how to make a .o file from a .c file. It automatically knows how to make a .a file from a bunch of .o files. And so the side effect of this is it's based on GNU, right? So GNU goes in there and tries to do this this thing where they have this auto configuration tool. And this is going to be building for a while, so I'm going to split the screen and then open up a new terminal. And then we can look at this in a little more detail. So project v128, and then we go into packages and then vice. So you'll see we've got this configure script. So configure is literally a script of some of the worst, nastiest looking shell script code you'll ever lay eyes on. Part of the reason for this is because this stuff is actually designed to work across every possible Unix system in existence. So it's a bit nutso. But the advantage of this is that it makes the source code configurable and runnable on just about every possible system in existence. So the thing to know about this is that the configure script is not human editable. It's actually generated from something totally different. And that's from these .ac files and these M4 files. So if we look at configure.ac, you'll see it's got these DNL lines in here. This is in a macro language called M4. And all of this stuff is designed to work with all of the GNU tools. So the reason why we had problems trying to build Vice is because I had left the source tree in a pre-configured state. Because when I was working on the video tree for the SDL side to get us that second head, I had to build it a bunch of times. And waiting for the top level scripts to go and build the software is pretty tedious. As you can see, it's taking a while. So I went in there and did a configure, and then I did my work directly there. And then when we went to go build it, Make saw that it was already configured and went and tried to use those scripts instead of trying to use the Make files that I had previously defined. There are ways around this, but that's the life of a software developer, right? Like, we always get into these weird situations where our tools want to do one thing, but we really want them to do something else. So I'm not clear on the CMake support. Is CMake functional? Is this something that we need to... Yes, there you go, build Vice. So I saw this CMake bootstrap script. And CMake bootstrap, if I can spell, generates the CMake lists files directly, which is kind of funny. But I may look into that later. That may be actually a better way of building it than what we're doing. But as you can see, the tree is now bringing in the dependencies that it needs. And once that is done, this is actually apt output, by the way. It generates this tarball and then jumps into the package build. So here you can see it's actually building Vice. And to do that, the first thing it has to do is it has to bring in all of the dependencies. And it's going to do that by just doing apt. Do an apt get install. It's going to bring in all the dependencies that Vice is going to need to build. And then once that's done, then it actually starts to build. And unfortunately, this is not a parallelizable task, so this takes a while. But on the upside, once it's built, we can install it pretty easy. So one of the things I meant to show is in packages. Oh, geez. You'll see that I've got this extra package here called MDT services. Vice itself will parallel build. In fact, I configured the Debian rules to take care of that. debos and debspawn do not parallelize their dependency fetching and installation, which is the trick. So that's unfortunately one of the side effects. But in any case, you can see I've got this MDT services tool. Now, MDT services is related to a project that I had a hand in building. If we go over to the website, the group I work in, or at least used to work in, is Coral. And this is a project inside of Google to build development boards for working with AI. And one of these tools is this board called the dev board, and this runs Linux. But one of the things that we needed was a tool to be able to manipulate this system a lot easier. So I created this tool called MDT. And MDT allows you to have a very simple way to access your development board, like a Pi 4 even, via SSH in a safe way. So this will allow us to do package installs. This will allow us to open up a shell on the machine and then just basically do all of our development work without having to rebuild a full image, flash it to the SD card, and then do that kind of rigmarole of trying to do all our tests. So since we have MDT services on here, this means that I can go into a shell and I can type MDT devices, and it's going to scan my local network, and you'll see that the v128 shows up in this list. So if I want to get on here, I just type MDT shell. I don't have to think about the IP address. I don't have to think about any of this stuff. And instantly, here I am on the v128. So when I do my work, the thing I do is I go ahead and build the software, and this is still doing the prereqs. So that's the downside of this. But once I've got the package built, I can then use a tool built into MDT called install to install the package on the device. So the workload, the work process, is essentially build the package and then do MDT install, and then we can do work on the machine. So, any other questions? This has been kind of a whirlwind thing. I wanted to give a rundown on how this stuff works, what I've got in the v128 project already. Aside from that, if you guys have any questions, feel free to reach out in the Discord. The Discord is actually linkable or linked on the YouTube site. Unfortunately, my site is currently down, but once I get this video edited and put up online, then we can hopefully get a discourse going and actually get into more things like actually doing code. I wasn't 100% ready to do much in the way of code today, but hopefully in the next couple of sessions we can get into more live coding exercises. It's going to be a mix of working on Vice, working on the v128, and then also it's going to be a mix of basically writing the dungeon game. So, and I have not forgotten that, and I am planning on working on that and finishing it. It's just, unfortunately, I haven't had much time. So, yeah. So, in terms of what we're working on, it's kind of a hybrid setup, right? So, it's both this software, it is also this hardware. Oh, I turned off my camera. So this hardware, it's this hardware, there's going to be some electrical engineering involved because we need to build a custom backplane for the compute module so that we can do 9-pin joystick support and then also floppy drive support, like actual floppy drive support. And then also we're going to make modifications to Vice so that this can all run together in a nice, smooth way. So hopefully that helps the confusion a little bit. But I had only planned on streaming for an hour, so I think I'm going to call it at this point. Thank you for joining the live stream, and thanks for bearing with me. I know it's been kind of a long time since I've done this. I'm hoping maybe we can augment some of the video production with live streaming and get more to doing this kind of thing on a more regular basis. So yeah, thanks for joining, guys. And we'll see you in the next video or live stream. Catch you next time.